Hello everyone, I'm Dr. Nikita Singhal. Today I'm going to start about industrial material, that is cement. In this presentation, I will cover introduction of cement, its raw material, how we can manufacture the Portland cement, its chemical composition and setting process. As we all know, cement is a basic ingredient which is used for construction purpose. It is a powdered material which have adhesive and as well as cohesive property. So it has capability to bind different materials like bricks, stones, building blocks, etc. It is made from a mixture of elements which are present in natural minerals like clay or sand or limestone. Cement can be divided into two categories. It can be hydraulic cement or it can be non-hydraulic cement. Hydraulic cement are those cement which needs water content to set and harden due to some hydration reactions. So these cements are known as hydraulic cement like Portland cement. While non-hydraulic cement are those cements which does not need any water content to get hardened, they get hard in dry condition. In today's market, Lafarge Holcim is the world's largest cement producer. Now coming to the Portland cement, it was discovered in 1924 by Joseph Asphodin. He found when he mixed the mixture of limestone and clay in presence of a small amount of water, he heated the mixture and found that it is turned into a stone-like substance, which resembles in appearance with the famous Portland stone, which is found in England. So its name is given as a Portland cement due to its appearance with Portland stone. It is a very fine mixture having calcium aluminates and calcium silicates. When they are mixed with water, they produces a hard resist mass. Its raw material are limestone and clay. Limestone supplies the calcium oxide and iron oxide. Clay provides the silicates and aluminates. As well as we need some powdered coal or fuel oil to heat or produce the gases, and gypsum is also added in cement in small quantity. Lime acts as a principal constituent. Its proportion must be regulated because its excess or lack can reduce the strength of the cement. Silica is mainly provides mechanical strength to the cement, while aluminates help for quick setting process. Calcium sulfate, that is gypsum, is used to retard the setting action, as well as iron oxide can be used to provide colors, hardness and strength to the cement. Now coming to the manufacturing process, it can be divided into four sections. First is mixing, second burning, third grinding and fourth packing. Now coming to the mixing process, raw material can be mixed in two processes. It can be dry or wet process. It will depend on the treatment of the raw materials. In the dry process, raw materials are crushed separately and they are ground. Then the powdered materials are mixed in required proportion to get dry raw mixture, and this is stored in different beans is known as silos or storage beans. Dry process is adopted when the raw materials are quite hard and this process is slow. Its quality produced by the dry process cement is not so good which in compared to the wet process. While in wet process, limestone is crushed in crushers and it is mixed with wet clay, which is already wet with water in wash meals. This limestone and clay is mixed in proper proportion in grinding meals to form a slurry which contains almost 40% water. Then it is compressed in air and this homogenized paste is collected in corrected beans. There its proportion can be corrected if it is required. Then it is sent to the storage tanks. These are known as silos. This method, wet process method, is usually used in India. It is adopted when raw materials are soft, climate conditions are fairly moist and fuel is cheap. This process provides a superior quality of cement. After the mixing process, we go for the burning process. This process is done in rotatory kilns, which are a steel tubing having the different diameter and length. Here, coal, fuel, oil can be used as a fuel sources to produce hot gases, which can produce around 1715 degrees Celsius maximum temperature can be obtained. the raw mix obtained from the dry process or the slurry which is obtained from the wet process is introduced as rotatory kiln from the upper end zone, while the hot flames using the fuel and air are produced from the lower end of the rotatory kilns. Due to slope and slow rotation motion, materials move towards the lower end or hottest zone. Depending on the different temperature condition, there are different sections are divided into the rotatory kiln. Like first is drying zone, which whose temperature is around 500 degrees Celsius. In this temperature, most of water gets evaporated from the slurry, and after that, in the central zone, the temperature goes high around up to 1000 degrees Celsius, and in this zone the limestone gets decomposed to produce calcium oxide and CO2. So the calcium carbonate is limestone which decomposes into calcium oxide and CO2. In the last zone, that is the cement forming zone, here it is the lowest zone where the temperature is very high around 1500 to 1700 degree Celsius. Here, the lime and clay get fused and forms the aluminates and silicate, which is actually the cement. So the calcium oxide and silica combines in different ratios. If it is combines in 2 moles of calcium oxide with silica, it produces dicalcium silicate, or it can produce a tricalcium silicate. We can abbreviate them C2S as a dicalcium silicate, C3S as tricalcium silicates. Calcium oxide can react with the alumina to form calcium aluminates, and in presence of iron oxide, it can form calcium aluminopherrites. From the reactions, a green, black or greyish mass is produced, which is known as clinker. This is formed in balls, and this clinker balls enter in rotatory coolers where it gets cooled down. After this burning process, we go for the grinding process. The cooled clinkers from the grinding process are from the burning process are ground to a fine material in ball mills. During this final grinding process, small amount of gypsum is added, which retards the dissolution process of calcium aluminates, and this calcium aluminates forms an insoluble product, that is calcium oxide alumina containing the gypsum. So this gypsum works as a retarding agent, and it prevents the quick setting and hardening process. This calcium oxide aluminum calcium sulfate is known as calcium sulfoaluminate. After the grinding process, this ground cement is stored in silos and it is fed to the automatic packing machines for the packaging purpose. Usually a cement kit is contained 50 kg of cement. Its average chemical composition contains the tricalcium silicates in almost 45%. Its abbreviation is C3S. Its setting time is around 7 days. While in dicalcium silicates takes more time for setting, is around 28 days. Its average composition is 25%. In compared to silicates, aluminates and aluminoferrites takes lesser time, almost around 1 day for setting, and its abbreviations like tricalcium aluminates represented can be as a C3A. Its and tetracalcium aluminum ferrite is represented as C4AF. Near about 10% amount is present in cement, except that calcium sulfate in form of gypsum, calcium oxide and magnesium oxide are also present in little quantities. Now, during preparation of cement, there is a setting process goes on. So we'll look for the setting and hardening of cement. When cement is mixed with water, and we allow to stand it, so it converts into a very hard resin mass. This process is known as solidification. It can be divided into setting and hardening. Setting is known as stiffening of original mass due to the formation of gel, while hardening is known as development of strength into the cement due to the crystallization process. Setting and hardening. During setting and hardening, there are different chemical and physical changes takes place. It is believed that aluminum silicate present in cement forms different hydrates with water, and these hydrates converts into gel-like structure, and gel contains lot amount of water, so it releases the water, so inside the core, and surface gets hardened. After the gel formation and its a dehydration process, it undergoes the crystallization process to harden the cement. Usually setting takes 1 day while the hardening takes around 15 to 20 days for cement. Now we'll look for the different chemical reaction which takes place during cement formation. Like calcium silicates undergo the hydrolysis process and forms the dicalcium silicate and calcium hydroxide. Similarly, tricalcium silicate and tricalcium aluminates undergoes the hydration process where they takes up the water molecules and get hydrated. So, hydrated calcium silicates and hydrated calcium aluminates are formed from hydration reactions. Tricalcium aluminates also combines with gypsum and it forms the insoluble products, that is calcium sulfoaluminate. Now, dicalcium silicate also takes up the water molecule and form the tobermonite gel, which has very high surface area. Here we can see in the reaction like 2 moles of dicalcium silicates combines with water and forms the tobermonite gel with calcium hydroxide. These all reactions are very exothermic, so temperature gets rise, and these all hydrated products undergoes the crystallization process where the interlocking occurs and cement get hardens. So in conclusion, we can say cement reacts with water and it gets hydrated. Firstly, tricalcium aluminate gets hardened and then tetracalcium aluminum ferrite get hardens. Dicalcium silicate and tricalcium silicates takes a lot of time for hydration reaction. Meanwhile, the gelation reactions starts for aluminates and aluminum ferrites. Slowly, silicates also undergo the gelation process. After the gelation, the hydrated products undergo the crystallization product to set the cement and provides a hardening. Now coming to the application part, as cement is used for civil engineering purpose, for construction purpose, we can say cement is used to prepare mortar, which is used for masonry work. It is used for prepare concrete. Cement can use for footpath making, different concrete rod, different foundations are made up of cement. It is used for construction of dams, bridges, tunnels, etc. Cement is also used for grouting. Grouting is a process where the cracks are filled using the cement. Thank you.